Now the next topic, that is solution of differential equation of first order and first degree. So a first order and first degree differential equation can be written as, that is, it contains order, derivative order first, and whose power is also 1, that is of the form f of xy dx plus g of xy dy is equal to 0. So this first order and first degree differential equation is not always easy to solve to get its solution. So there are so many methods to solve such type of differential equation. So we will discuss here how can we solve to obtain the solution of differential equation. There are so many forms. So the first form is method of variable separable. That is, in this method we will get equation in two variable and its variable can be separate. That is, at the one side, that is maybe left side, we will get variable in the y form, and on the right hand side we get the variable in the x side. Then after integrating that both sides, we will get the general solution very easily. So the first method is method of variable separable. So in this method, differential equation f of xy dx plus g of xy dy of first order and first degree can be changed into p of x dx plus q of y dy if and only if f of xy is a function of x only, say p of x, and g of xy is a function of y only, say q of y, then above equation is said to be equation in variable separable form, and its solution can be found out by taking p of x dx on left hand side and minus k of y dy on right hand side, then integrating it. That is, on integration we get p of x dx plus q of y dy is equal to c, where c is an constant of integration, that is arbitrary constant. So this is the method of variable separable. That is, in this method we will get a function that contains only y variable and a function that contains only x variable, and by separating these function and after integrating we will get the general solution of this first degree and first order differential equation. Now we will do the problem based on variable separable method. So the first problem is solve the differential equation x into 1 plus y square dx minus y into 1 plus x square dy is equal to 0. Now the solution is, here we have x into 1 plus y square dx. By taking y into 1 plus x square dy on right hand side, we get this form. Now we can separate the variable as x dx over 1 plus x square and y dy over 1 plus y square. Now on integrating, we get, that is, if we take 1 plus x square as t, then 2x dx will be its derivative. In the same case, 1 plus y square as z, then 2y dy its derivative. So we multiply both sides by 2 in the numerator to get this form, that is 2x dx over 1 plus x square, 2y dy over 1 plus y square, that is derivative over function. So as we get derivative over function of integration of this part, then it becomes log of function, that is log of 1 plus x square is equal to log of 1 plus y square, and we take constant as log of c. So we get log of 1 plus x square minus log of 1 plus y square is equal to log c. So log m minus log n is equal to log m over n. Therefore we get log m over n is equal to log c. So as these are the facts, log x is equal to log y, that gives x is equal to y. Therefore 1 plus x square over 1 plus y square is equal to c. That gives 1 plus x square is equal to c times 1 plus y square, where c is an arbitrary constant, and the above solution is the general solution of given differential equation. So the next problem is solve the equation, that is e raised to power x plus e raised to minus x into dy by dx is equal to e raised to power x minus e raised to power minus x. Now the solution is, as we have e raised to power x plus e raised to minus x, dy by dx is equal to e raised to power x minus e raised to power minus x. So from here we can see that dy is equal to e raised to power x minus e raised to minus x over e raised to power x plus e raised to minus x into dx. So here variable are separated. Now we can take integration. So integrate it, we get integration of dy, integration of e raised to power x minus e raised to minus x over e raised to power x plus e raised to minus x dx. If we see, if we take here t is equal to e raised to power x minus e raised to minus x, then dt is, sorry, e raised to power x plus e raised to minus x, then dt is, its derivative is same. E raised to minus x is e raised to minus x into minus 1, derivative of minus x. So we get dt is e raised to power x minus e raised to power minus x. That is, we get dy is equal to dt over t. That is, we get y is equal to log t plus c. So here we can substitute the value of t, that is log of e raised to power x plus e raised to minus x plus c. That is general solution of given differential equation. Now the next problem is solve dy over dx is equal to e raised to power x minus y plus x square into e raised to power minus y. Now the solution is dy over dx is equal to e raised to power x into e raised to minus y plus x square into e raised to power minus y. So from here we can get e raised to power y dy is equal to e raised to power x plus x square dx. Now the equation is variable separable form. So integrate it. We get e raised to y dy is equal to integration of e raised to power x plus x square dx. That is, we get e raised to y as it is, e raised to power x as it is, and integration of x square is x cube over c plus c, which is the required solution of given differential equation, and it is in journal form. Now we will do the problem based on variable separable, in which we will find particular solutions. So the problem number 4 is find the particular solution of the differential equation dy over dx is equal to y tan x, given that y is equal to 1 when x is equal to 0. So now the solution is, as we have dy over dx is equal to y tan x. So by variable separable method, it becomes dy over y is equal to tan x dx. Now on integrating, we get, that is, integration of dy over y is equal to integration of tan x dx. And integration of tan x dx is minus log cos x, as we know that. So it becomes dy over y is log y, which is equal to log of minus log of cos x, that is the integration of tan x, plus, to make the question easy, we take constant as log c. C is the constant of integration. So in this we see, that is log y plus log of cos x is equal to log c. So in the left hand side we have log m plus log n, which becomes log m into n, that is the property of log, which is equal to log c. So that gives y into cos x is equal to c. So as we have to find particular solution and at x is equal to 0, y is equal to 1, that is we get 1 into cos 0 is equal to c. Cos 0 is 1, therefore 1 into 1 is 1, therefore c is equal to 1. Hence, particular solution is y into cos x is equal to 1. By substituting the value c is equal to 1 in the solution, y into cos x is equal to c. So we get y is equal to 1 over cos x. So the solution is y is equal to secant x. So y is equal to secant x is a particular solution of given differential equation. As we see, particular solution does not contain any constant. Now the next problem is solve dy by dx is equal to x plus y whole square. So in this problem we can see that it is not easy to separate the variable, because if we open x plus y whole square, it will contain x square plus y square plus mixed term of x and y function. So it is not easy to solve this question by variable separable method as directly. So there is a technique, let x plus y is equal to z, new variable. So differentiate with respect to x to get the value of dy by dx. So we get x plus dy by dx is equal to dz over dx. That gives dy by dx is equal to dz over dx minus 1. So this is number 3. So using 2 and 3 in number 1, we will get dz over dx minus 1 is equal to z square. Now it can be separated. So here we see that dz over dx is equal to 1 plus z square. Now variable separable method can be used here by obtaining this separated form of variable. So this is our required equation to solve the variable separable method. So this is the variable separable method, then integrate it. We will get, that is integration of dz over 1 plus z square and integration of dz. So integration of 1 plus z square is tan inverse z is equal to x plus c. As z is x plus y, so replace z by x plus y. So which is the required general solution? Of given differential equation.